welcome back to episode 4 of StudyMonster's Programming with Python video series. In this one we're going to be looking at everything integers and float values.
Right, so first thing we're going to be looking at is the difference between an integer and a float. So first things first, we're going to create two variables. So like we discussed in previous videos, and I would recommend if this is the first time you're watching this and you're new to Python, go back and watch the first couple of videos, first 3 videos that we've done. We're going to create a variable called age, and we're going to use the assignment operator, which is the equals, to create a variable, and we're going to put 15 in it, so an integer value of 15, and we're going to look at what these mean in a minute. Now the next variable we're going to make again, and if you remember back to a previous video, we talked about making sure our variables, they can't have spaces in, they can't start with a number. There's rules around how we name our variables. So I'm going to call this one height underscore m to signify it's containing height in meters. So make sure these variable names are meaningful for when you go visit your code again. And I'm going to assign this one the value of 1.83. Now, so what do these mean? Well, we've got 15 in age, and I'm going to put a comment on this line of code. Now remember, previous video we talked about how your comments can come before code, and they can also come after code, they can also come in line with code. So just to keep our code nice and neat for when we refer back to it, I'm going to explain what this line is. So age is an integer. So integer values contain whole numbers. So a whole number is an integer. So this 15 has got no decimal points. And as you can probably guess from that point, the float value, which is also sometimes called real, these are interchangeable values. You probably in your GCSE exams you see it referred to as real, but it basically real is a float value. It's a floating point value. So float values contain numbers with a decimal point. And that's the difference between an integer and a float. Now, another little handy function that you can use if you're writing code and you want to see what data type is within an actual variable, you can use a function called type. So another little comment here, sorry, and we're going to say, if you're curious, so if you're curious about the data type within a variable, if you can spell variable, the type function is your friend, right? And we're going to look at how we use that now. So if we print, and we're just going to print a little title first so that we can read it down in our shell a bit easier. So if this little bit of code here doesn't make sense, please, like I said before, refer back. So we're just going to create a new line first, and we're just going to call it data types. So this is a little title for what's going to come below. So data types, you can see my IDE is trying to help me here. So I'm going to change this up a little bit. We're going to do print. And if you remember back, we talked about printing literal strings. So if I use the speech marks, this means I'm going to print something out. I'm going to hard code some string information into my output area down here. So I'm going to say age, actually we'll capitalize it. So the age variable, can't spell variable again. Variable contains, and then we'll do a colon, and we're going to concatenate age, but this time, in fact, I'll let my IDE speed it up a bit and do them all. We're going to use the type function on age. And remember, it's really important, a lot of students get this wrong. When I typed that variable in there and I opened this bracket, it didn't automatically put that one in. Make sure when you open a bracket, you've got the correct number of closed brackets. So I've opened one, and then I've closed 2. And we're just going to shove the type function in before our height and close that one again. And then we're going to see what it comes up with down here. So when we run that code, we've got our little title, data types. So the age variable contains class int, and the height variable contains class float. So it's telling us, using this type function, what these variables contain. So remember, integers are whole numbers. Floats or real values are numbers with decimal points. Right, so difference between integers and floats, we've got that now on to our next part of the lesson. So we're going to look at numbers v strings. So we talked quite in depth in our last video about string values, and it's really important that you understand the difference between a number data type like an integer and a float and a string value. So we're going to take a quick look at that now. So it's really important if you think about the number 100, but then also the characters that make up 100, so 100, Python will either recognize it as an integer value, a number that you can then perform maths on, or as a string value, which is just containing the characters 100. We won't be able to do mathematics on it. So first thing we're going to do again is we're going to create two variables. So this time, thinking about how a variable might be used with a number value in it, we're going to call it score. And this time I'm just going to tag on to the end number, because I want to make sure that we're going to put an integer in here, a whole number. So this one, very quickly, another little quick comment, contains an integer. Okay, so next one we're going to do score, and I'm just going to call this text because this is going to contain a string value, and we're going to do the same again, but we're going to put it inside of quotation marks to signify a literal string, and we're going to give it a quick comment, so this contains a string value. Whoops, and we'll do an. Contains a string value and contains an integer. So we've got two variables, score number, score text, that contain the same thing but of different data types. So next we're going to sort of see what happens when we use them. So first thing is we'll do another little title. We'll say print, and again we're going to put it on a new line. Oops, new line, so I need a backslash there, backslash n. New line, instead of data types like our last one, we're going to do numbers, these strings, and we'll close that off. Whoops, so IDE is trying to be too helpful there, we don't want that. So next thing we're going to do is we're going to print, and we're going to say the score number, whoops, score underscore number. So this is our variable that contains our integer value, and we'll do a little colon, concatenating alongside of it the actual contents of that, so score number. So it should print out here score number, then 100. And we're going to concatenate alongside that, and we'll say, whoops, speech marks again, type. So we're going to look at what type it is, and we're going to say type, whoops, yeah, type, sorry, concatenate that, type, and then score number again. So this should print out a nice, we'll run it actually now and see what happens. So when we run this, we've got strings v numbers v strings, so score number is contains 100, and it's a type of integer. Okay, so we'll do the same thing, and hopefully our ID will help us here. Put the other bits on, so score text, just to speed the video up a little bit, and we run that, and we've got score number is 100, type class integer. So similar, very similar thing to what we've done in our last one, but this time we're going to look at the consequences of these data types. So strings don't behave like numbers, and this is really important because again, this is when you can spell string properly, it will be a lot better. Oops, doesn't have two G's. This is where a lot of students will lose marks because they'll try and perform maths on string values. So if we do quick print statement, and we will say, for it again, we'll put it on a new line so it's easier to read. So we're going to say string, how we're going to do this, so string 100, and you'll notice here that I'm using single apostrophes here as opposed to my double. So I always like to put my literal strings in double speech marks in when I'm dealing with numbers and I want to signify a number within a string. I use a single apostrophe. So plus, so when we add 100, a string 100 to another string 100, so string 100 plus another string 100 is, in fact, we'll do equals, and then we will close our string and concatenate the score underscore text plus the score underscore text, and that should work. So now what we would expect if we weren't aware of how strings and numbers operate, we would hope that this 100 would be added to this 100 and we would get 200. But because this is a string value, and when we run it, you will see that we've got 100, and 100 is 100 plus 100. So basically it's just joined them two strings together. So it thinks you're just concatenating them. Basically you're joining them together. And then we will see how, and hopefully our ID is going to help us here. No, it's not. See how this is going to run for our number. So, whoops, our string value. So we're going to say number 100 plus 100 equals, and then we will concatenate our score number. Whoops, not score text. Score underscore number. So let's see what this one does. So when we run this, our string value is 100 string plus 100 string gives us the two 100s joined together. But because this number, this variable, which is score number, contains an integer value of 100, it's able to perform maths on it. So this plus here is performing maths, is performing arithmetic. This plus here, because we're dealing with a string value, is performing concatenation. It's just joining two things together. Okay, so on to the third part of this Python video. So we're going to be looking at casting, so converting between types. So casting is a technique that allows you to take one data type and then convert it into a different data type. And we're going to cover this a lot in future videos. And first of all, like normal, we're going to create some, whoops, we're not going to spell it like that though. We're going to create some variables. So this one we're going to call it coin text again. So this is going to be a string value. So coin text is going to be equal to, and we'll do a string value of 25. So we've got 25, supposedly 25 coins there, but it's a string value. So we've got, remember the string literal, the characters 2, 5, they're not numbers at this point. And then we're going to call this one coins underscore number. And we're going to now perform some concatenation. So in a previous video, we mentioned different concatenation functions. So we're going to convert this string value here into an integer. So to do that, we use the int function, and then we pass into the int function, if you can spell like I clearly can't, the variable coins text. So when this line of code is run, the value, the string value 25 is inside of this coins text variable. When we then run this second line of code here, it is taking the coins text variable, passing it into the integer function and converting it into a number, a whole number, and it is assigning it to this coins number variable. So a few little quick comments. So text, just to keep everything nice and tidy. And this one is converting text to an integer, right? Nice and simple. So let's see and make sure these work. So we're going to print our title again. So again, check the last video if you're not sure what this is doing, if I can even do it right at this point. So we're going to call this one casting. So casting, type conversion. So there's our little title that we've got ready. So print, and this time we're going to say, similar to what we've done before, we're going to say, whoops, make sure it's spelled the same. So coins underscore text first we'll do. Coins underscore text is, and we'll say, oops, don't need that space because we're going to concatenate the coins. Can't spell coins, I have no idea why I can't spell it there. Coins text, comma, and we're going to say type again, type coins text. So this one is going to print out coins text is, it's then going to display what is ever inside of this. So it will display 25 and then tell us what type it is. So it should say of type data, class, sorry, string, str. So we'll try that and see what happens. So we have got coins text is 25 and the type, the class is a string value. So it knows that we've got a string value at this point. Next, we're going to do the same thing, but for our next variable. So coins number is coins number, so it should display 25 and tell us that now the type. So these up to this point, everything should be the same the next time we run this, but the class will be different because we have converted it, we've casted it in from a string into an integer. So we've still got the same lot, 25, 25, but the class is a string in the first instance. The second time it's an integer because we've performed this here, this casting. And we can do exactly the same thing with a float value. So let's do price. So price text, and we'll do this really quickly. Price text equals, or actually we'll make it a float, like I said, $3.99, and we'll do price number and then convert it. So we're casting it. So we're doing exactly the same thing, casting it there, and then we will do casting type conversion again, and we will price text first, and then we will do price number. So let's see what happens here. Whoops, and we've got an error. So where's that error coming from? Line 41. Price number, or int, because we don't want it to be an int. We would like it to be a float because we've got a float here. So it can't convert it into an integer because it's got a decimal point. It's got a point in there. So we need it to be a float. And then we'll try running that again. So we've got price text in the first instance is 399, which is the string value 3.99, and it's a string. Second time it's run, because we've performed this casting, it has now converted that 3.99 into a floating value which can handle the decimal point, whereas before I had it as an int and it was trying to convert it into an integer, and it was saying, well, I can't do this because the integer, this number that you're giving me, has a decimal point, and the integer can't store a decimal point. And that is it for casting. Right, so casting, we're moving on now to arithmetic operators. So with these number data types, the integer and the float, Python allows us to perform arithmetic on them, so basic math. So starting off, now I wouldn't recommend this, like we mentioned in a previous video, having variables with a single letter is kind of a no-no. Make sure the description, but for the purposes, descriptive, sorry, the purposes for this one, this example, we're just going to keep it as a and a B. So we're going to create two variables, A and B. A contains the integer value 12, and the B integer variable, sorry, contains an integer of 5. So let's get to work on some basic arithmetic. So if we first print out a little title so we can read it a little bit better down the bottom, like we've been doing in previous ones, we will call this one arithmetic with integers. So there's our title. Right, so first thing we're going to look at is addition. So we're going to print, open and close our parentheses, and we're going to print out some literal strings, literal information, so we can read it a little bit better in the console. So we're going to say A plus B is equal to, and then we're going to concatenate, and now we're going to put in our actual arithmetic. So we're going to tell Python, can you take the variable A and can you add the variable B to it? And we're just going to close that. We're not going to do types anymore because we've seen that too much now. And we'll put a little comment at the end. So we're just going to say addition. So this is addition, and let's run it and see what happens. So we'll run that, and we should see down here, arithmetic with integers, A plus B is equal to 17. So it's added, took 12 and it's added 5 to it. And then this is going to get very, very obvious what's happening here. So we're going to take A and we're going to minus B from it. And this is clearly subtraction. Let's run it and see what happens. So it's took 12, subtracted 5 from it, and it's given us 7. Next, we are going to multiply, and we are going to multiply 12 by 5 and see what we get here. So we've got the value 60. Okay, now when it comes to division, I would like to do another little title here, because division, there's more than one division. So there's 3 types of division in Python. There's standard division, there's floor division, and then there's modulus, which we're going to look at. So first things first, though, we are going to, in fact, we'll do standard. So we'll do standard and then we'll look at the others next. So standard division. So we will do A divided by B equals A divided by B, and we will call this one standard division, and we'll see what happens when we run this one. So we've got 2.4. So bear that in mind, because we're going to do the others in a minute. But before we get to that one, we're going to do missed one here. So we'll do a slightly different one here. So we're going to look at exponentiation, so to the power of. So another one we can do is, and we will write this out, A star star, which is to the power of B. And this one is a little comment in there, and this is to the power of. So if we run that code and see what happens there. So A to the power of B gives us, what is that, 248,832. And then we've got our, let's put that in itself, we didn't actually type that, it's trying to be too helpful for us. So we've got our to the power of there, which has given us 248,832. And then we've done a standard division, which has given us, taken A and dividing it by B, and it's given us 2.4. So next we're going to be looking at the division. So we're going to be looking at floor division. So it's going to give us how many times 5 goes into 12. So it's basically going to drop this decimal point. So floor division. So if we do print, and it's given us it there, it's it's way too helpful, this IDE. So we're going to do A, and it's 2 forward slashes by B equals, and we're going to concatenate that calculation there, and we're going to call it floor division. This basically chops the decimal point off, so it's telling us how many times 5 goes into the number 12, so we should just get 2. So we've got A using floor division by B gives us 2, so 5 goes into 12 twice. And then finally we've got our last form of division, which is modulus, and you use the percentage sign. So we're going to say A, oops, not and, percent B is equal to, and this one is, it's called modulus, so it's going to give us the remainder of a division. So it's not going to give us anything, it's going to get rid of this 2, and it's just going to give us the remainder. So if 5 goes into 12 twice, and then how many is left over. So this is the remainder of a division. Let's see what we've got when we run this one. So it's telling us that there's 2 left over. So 5 goes into 12 twice, and it's got 2 left over. So that is the remainder of that division. And again, you can do all of these things with float values. So it doesn't matter if it's an integer or a float value. But just one quick note, this floor division, so floor division will always return an integer because it's going to get rid of that decimal point. So if you perform this calculation of floor division using 2 forward slashes, your data type that is produced is always going to be of an integer value. Right, so having moved down my divisions into the actual area I was supposed to do it, we are now going to skip past 5 because it's done. We've done it in 4, and we're going to go to our 6th part of the lesson. So assigning a calculation to a variable. So we're going to continue to use these A and B variables for this one. And it's just a quick reminder that we can not just print out a calculation like we've just been printing them so far. So A minus B, and then printing that value out. We can actually store that back inside of a value. So we'll just make a couple of variables that make sense to the arithmetic that we're performing. So if we do total equals A plus B, that is going to store the value of 12 plus 5 inside of the variable total. We're going to do a difference. So that will be our minus 1. So equals A minus B. And again, there's no real a lot of students when they're learning Python, they'll do things like this. There's no difference between A plus B. I like to keep my code easier to read by just putting in spaces, so don't worry about that. It's just the way that I like to type my code. Next one, we're going to do the product. So the product is going to be our multiplication, so product of A multiplied by B, and then we'll do quotient, so the value that is left when you divide one number by another. And there we've got four variables with suitable names, and we've got our arithmetic calculation being assigned into them, and we'll just check that they are working by printing them out. So print, and we'll say so we're going to do our little title like we've been doing on our others, and we'll call this one assigning calculations to variables. And first off, we're going to do total is total. I'm going to change that up a little bit, and I'm going to just add in, instead of these, I'm going to do equals. Just thinks it looks a little bit nicer. And there. So let's see what happens when we run that. So we've got assigning calculations to variable. We've got our 17 stored inside of our total, 7 in difference, 60 in product, and our division, our standard division stored there. So that is just ensuring that you can understand that you can store a calculation inside of a variable, and you can update variables. So these could be updated as we go through our program. So remember, a variable can change, it's not fixed. Okay, so like we were saying earlier, we can update these variables. Because we've assigned this calculation A plus B into total doesn't mean that it's always going to be the value 17. We can change these. So we're going to update some variables, so reassign values. So let's say, for example, we're making a game and we've got a nice variable called XP, and currently it's got an integer value of 10. Well, we're going to print that out first. So we're going to print, and we'll do a little title again. So we're going to do \n, updating a variable. So we're going to update this XP variable, and to do that, we're just going to print XP currently, so what it currently equals. So XP is equal to, in fact, we'll make that read a little bit better. So we'll say starting. So starting XP is equal to 10. That should print. So we'll test that and run it. So we've got starting XP is equal to 10. Right, so now we're going to start updating it. So we can do it in a few different ways, but first off, we're going to do, now you can see my ID is offering us this shortcut way. So plus equals 10. I'm going to show you a different way to do it first of all, because that's what I wanted to do next. So we're going to do XP equals XP. So it's taking the value of what is inside of XP, and then we are going to add, and we'll just add 5 to it for now. And then we will print that out. So we're going to say, we'll say something like, after gaining 5 XP, after gaining 5 XP, XP now equals whatever it equals. I'm not going to get rid of that because I don't want to show you that yet. So then we will run it and see what happens. So we've starting XP is 10, but after gaining 5, so after adding 5 to the XP, it's now equal to 15. So let's double it. So we've hit a power up, and we're now going to double our XP. So we're going to say XP is equal to XP multiplied by 2, and print, and we're going to say after double XP, or doubling our XP, XP is, type is in there so it makes a little bit more sense, is now XP. So let's see what that does. So started off at 10, we added 5 to it to get 15, and then we have doubled it, so we've now gone XP is now 30. So just jumping back slightly, when the IDE, so PyCharm that I'm using, was trying to help us, and it was different ways of updating or reassigning these variables, and it showed you a little shortcut. So the years, and I'll just do a little comment here, so the years shortcut operators, and it's the same idea as what we've done above. It's just shorter. That's literally the only difference. There's no right or wrong way to do this. So we could do just very quickly XP plus equals, and then we'll add 3 to it. So that is basically saying XP equals XP plus 3, but we're just doing it in a much shorter way. So print, and we will do after gaining, whoops, not ganging, after gaining 3 XP, XP is now, and then we'll do the same again before we run it and test it. So XP is multiplied equals, and we'll double it again. So we'll just keep doubling it. Print, and we'll go after doubling our XP. XP is now XP. So let's run that and see what we get down the bottom. So our initial starting XP was 10. We added 5 to it to get 15. We then doubled our XP and got 30. We then added 3 to it, just using the shorter version of reassigning our values. Is now 33, and then we doubled that to 66. So 2 ways of updating or reassigning variables. Right, so on to the last part of this video for integers and floats. I'm conscious we've just been dealing with a lot of integers at the minute. Float values are numbers with decimal points. So we're going to be looking at a very, very, very useful function called round, which is for rounding our numbers. It's really useful for when you perform a calculation, especially divisions, when you want to restrict the decimal places. So let's create a variable called pi. Now, some people watching this, if you're used to program, you might say, well, that's not a variable because pi doesn't change. That's a constant. We'll talk about that in a different video. For this one, we're going to do pi to 1.4, and I've got this wrote down, so I don't actually know this off by heart. I only know it to 2. So 1415926 Right, so there's pi to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 decimal places. So we're going to use the round function. So let's create our little title like we have been. So /, oops, need our brackets, /n, and we're going to call this one rounding. Nice and simple. And then close our speech marks and our bracket. So first thing we're going to do is we're just going to print pi out. So we're going to say print, and we're going to go pi is equal to, at the minute, comma, pi. So let's have a look and see what that does. So that's just going to print out pi with 10 decimal points. So next up, we're going to now introduce the round function. So we're going to print, and we're going to say round pi, round pi even. So if we just do round and we just do pi, pi, so we're not rounding it to anything, and this will make a little bit more sense after I've finished this, and we're going to concatenate that, what we've actually put in that little literal string there. So we're going to say round pi, but with no additional arguments. So pi has 2 arguments. We're just going to leave it and just say print pi out in round. Now what that's going to do is it's going to round it to the nearest whole number. So if you don't tell it how many decimal points you want to round it to, it will just do it to the nearest whole number. So I'll just make a little comment on that, saying nearest whole number, and we'll run it. So what is the nearest whole number? Well, the nearest whole number is 3. So it's just going to round it to 3. So now let's start rounding it and specifically telling in our arguments how many decimal points we want to use. So we'll do the same sort of statement again. So round, open brackets, pi, comma 2. equals, and we'll do that. And this is clearly going to round pi to 2 decimal places. And let's see that in action. So we run it, and now we've got pi to 2 decimal places. And again, we'll do it again. We'll do 4 this time. So print, and our last one before we finish, we will round pi not to 3, we'll do it to 4. And we will run our little comment on, make sure everything's nice and easy to read. If we come back to this, to 4 decimal places. I can't emphasize enough for people that are learning how to code that you comment everything you do. So there we've got it rounded to 4 decimal points, and we can see there that that 9 means that that 5 is going to go to a 6. So we've rounded it to 4 decimal points there. So that is the round function on a floating value.
And that's a wrap. Everything for integers and floats. If this video has helped you, please like and subscribe for more. Help share the channel if you can, and I will see you in the next one. Bye for now.